Hi everyone and welcome to this new video. In this video I want to introduce a platform that you can use to learn and practice your Linux skills, and this is the OverTheWire.org website, which offers various wargames. So the idea is that wargames are like challenges that you can use to challenge your understanding of the Linux operating system, of the various commands you can use in Linux and things of the sort. So in this website we see the various wargames. So the wargames offered by OverTheWire community can help you learn and practice security concept in the form of fun-filled games. So the first one, which is also the easiest, is Bandit, but then you have also more complex ones. So today I would say let's start to do together some levels in Bandit. So the Bandit wargame is aimed at absolute beginners. It will teach you the basics needed to be able to play other wargames. So this is why I want to introduce this level, because I just finished the Linux privilege escalation series. Now for those of you who have no clue about Linux or who don't really use Linux that much, this kind of wargames can be extremely useful to just get started, because they will ask you to do basic stuff like connecting to an SSH server, use some command line programs and stuff like that, that allows you to practice and to get used to this way of working with the command line, which is of course extremely useful when you want to do privilege escalation. So this game, like most other games, is organized in levels. You start at level 0, you try to beat or finish the level to obtain the new level. So like information you obtain in level 0 will allow you to go to level 1. So you will encounter many situations in which you have no idea what you are supposed to do. Don't panic, don't give up. The purpose of this game is for you to learn the basics. So that's the idea essentially. And in particular, the basics initially is just introduction to the user to the basic commands in Linux. So we can start directly with level 0. So the goal of this level is for you to log into the game using SSH. The host to which you need to connect is bandit.labs.overthewire.org on port 2220. The username is bandit0 and the password is bandit0. Once logged in, go to the level 1 page to find out how to beat the level 1. So the first goal is pretty simple. Connect using SSH. Now, if you've never connected using SSH, however, this can still be somewhat hard. So what's the idea here? Now, SSH is a network protocol that offers shell functionalities in a remote way. So the idea is that when I have a local shell here in my machine, I'm literally interacting with my computer. So this is a local shell. If I send a command like whoami or hostname or stuff like that, here I'm extracting information from my own physical computer that is sitting right here in front of me. So that's the idea. When I do SSH, the idea is a bit different, because now I have a client and I have a server, and this SSH command allows me to obtain a remote shell. So a shell that looks like this, however, it doesn't execute directly on the client. This would be a local shell, but it executes on the server. So this is a remote shell. And SSH is the program to obtain this shell in a secure way, meaning that the communication here is encrypted and is also protected with respect to integrity and authentication purposes. So that's the idea. So all these kind of network commands, they always require you to specify an endpoint, so a network endpoint, and some kind of authentication information. Now, when it comes to the internet, SSH works on top of TCP essentially. So the stack is I have TCP, and then on top I have SSH. This is different, for example, from the HTTP, because the HTTP is also on top of TCP. So SSH can be considered an application level protocol that offers a remote secure shell. So how do we specify the endpoint? Well, essentially we specify it with two different information, because this endpoint essentially has to be the TCP socket that will listen for incoming connection on the server. And a TCP socket is defined by an IP address and a port. Now, since we don't want to remember all the time the specific IP address of our machines, we can use the DNS domain the DNS system, which is a distributed database of names that maps names to IP addresses. So the idea is that we can use this bandit.labs.overthewire.org. This defines a domain and the domain itself is mapped to an IP address. So at the end, the TCP socket requires an IP address, but we don't need to specify it. We just need to specify the domain that then is linked to the IP address. So to connect itself, how can we do this? Well, it's simple. We do SSH, which is the name of the command. Then we put the domain, which is bandit.labs.overthewire.org. And then we put the so to put the port, actually, we need to look into SSH commands, into SSH options, because each command can have multiple ways of working. Now, typically, SSH uses the 22 ports to connect to a host. This means that if you just put like something, like in this case, if you just put Bandit Labs over the wire, and you just do this connection, it's going to use the 22 port, which I don't think we have the password for that. So you see, you are trying to log in into this SSH port on port 22, which is not intended. So the default port of SSH is not the one we need to use. We need to change the way SSH command works. So how do we do that? Well, the idea is that let's look at the options offered by SSH with SSH-help. Here we see the usage, and specifically look at this. If we search for port, here we see this -p port. It means that if we want to use a different port than the one initially assumed by the command, we have to do -p and then the new port. So in this case it would be 2220. So let's do that. So we do SSH like this, but then we can do p 2220, and we do like this. If we do like this, notice what's gonna say. It's gonna try to authenticate as the user Leo. Because look at this, Leo at bandit.labs over the wire. Now, the user we actually want to use is not Leo. Leo is the user on my current machine, but rather is bandit0. So how do we fix that? Well, the syntax that SSH uses is we have to put the username, then we have to put an @ symbol, and then the domain name. So once we do this, look at this. Now we are trying to authenticate as the user bandit0. We put the password bandit0, and we should be inside. And we are inside, actually. Look, the prompt changed. Now it's green. It's different from the one local. Look, this is changed because here I have arch, here I have bandit, this is green, this is not green, here I have this square, and here I don't have any square, and stuff like that. So the prompt has changed, and if we do a host name, we see that we are currently in bandit, and currently I am bandit0. So this is essentially the first level. Of course, what can we do once logged in? Well, let's try to check, for example, the files in the current directory. To get the current directory, we can do pwd, and it tells us that we are currently in /home/bandit0. We're gonna do a simple ls, and look at this. We have this readme file. So let's cut the readme file, and it says, congratulations on your first steps. The password you're looking for is this one. So this is the password, and of course, to remember it for next time, we can actually just remember it like here, so we can put this here, and then we can put the command that we use. So I always suggest when you do this kind of stuff, you can do exit. It's gonna drop the connection, and then we're gonna just keep note of the password. Password is also bandit0, and we're gonna keep track of the commands we use to complete the level. So with level 0, essentially we are done. Now we have the password for the next level. So let's go into Chromium to check. So level 0 is done. Level 1. The password for the next level is stored in a file called readme located in the home directory. Use this password to log into Bandit1 using SSH. So the idea is that when we find password files, these are the entry level for the next level. So, for example, in this case, we saw this password, which means that this password is actually going to be used to connect to the next level of the Bandit Labs. OverTheWire.org. Okay, OverTheWire. Okay, and the password is this one. I think Bandit... oh, the port, of course, is 2220. And then we put the password, and we are in with Bandit1. So this is the first level. Now, so essentially, this is how we go from level 0 to level 1. Let's go to the next, from level 1 to level 2. And also notice that here they say, look, password can change, and some levels when you go into the chain can be difficult. So it is really important to take a good notes on the various progress you make in the various labs. Like for example, in this case, I assign the SSH command and assign the readme file. So I guess here I can put readme like this. So just so that I can remember in the future how I got there. So let's go level 1 to level 2. So let's read. The password for the next level is stored in a file called dash located in the home directory. So interesting. Okay, let's see. Let's see what we get here. Okay, look at this. There is this little file called dash. Now, how can we actually read the content? Let's try to do maybe a cat and then the file name, right? Notice what happens. Nothing happens actually. We are not reading the file. This is because dash is actually a meaningful command for bash. So bash confuses the meaning associated with dash and is not able to really read this particular file. Now let's try to, for example, quote the dash in the single quotes. Once again, this does not work. Let's quote it in double quotes. Once again, this does not work. So how can we read this kind of specific file name? Now there are different ways of doing this. For example, one that actually works is we do cat, then we do dot slash, which means read the file starting from the current directory, and then we put a dash. In this way, the cat program does not confuse itself by interpreting dash as a special command, but rather it understands, okay, I need to read the file called dash from this directory. And look at that, we obtain our specific flag. Otherwise, you can also do a redirection of you change the standard input of the cat command with the dash like this. So this also works because cat takes the input and puts it into the output. So it just prints out what it received in input, and in input you make it receive the dash file name. Another thing that works, for example, is if you do xstamp and you do dash dash and you do dash, this also works and it gives you the raw bytes, hexadecimal bytes of the file. If you want then to print also the ASCII version, you can do dash C, capital C, and look at this, here you have also the password. It's a little bit difficult to format, but you can also work with that. And this double dash is meant to separate all the options from all the arguments. So in this way, you're saying to the shell, to the bash interpreter, okay, before the double dash, you have all the options. After the double dash, you have all the arguments. So this single dash is not considered an option anymore, but a file name, which is an argument for xstamp. Because if you look at xstamp help, you see that essentially the arguments are the files, and then we have a bunch of options also. Now, as you can see here, the ambiguity is with respect to the fact that the options are specified with a single dash. So if I specify a file with a dash, xstamp will have an ambiguous relationship with this dash, because it's going to be like, wait a second, is this an option or is this a file? To remove the ambiguity, we just separate the two clearly by this double dash command. So we do double dash, and then it knows, okay, this first is options, and then we have file name. And so we apply the option C, which is canonical, so canonical ESC plus ASCII display on the file name dash. So it's also important to mention, however, that what I said about the dash dash being the separator with respect to options from arguments, this also depends on the specific program. Like for example, in xstamp, it's not really needed because I can just do this. So I can just do this essentially, and it still works. For some other programs, however, if you cannot like make it work, if the program is ambiguous with respect to the options or the arguments, you just put a double dash and it should also work. So essentially that's the idea. However, we were able to read the password, which is what we wanted, also like this. And so we can just write it, so like various commands to read the dash file. For example, this one. For example, xstamp dash, xstamp dash dash dash. We do cat with the redirect of the of the input like this. Then the password for next level is, and then we put the password for the next level, which is this one. Perfect. So also this level is, we can do done essentially, and we can go to the second level. So this is first second, this is second third. So in this case, the password for next level is stored in a file called spaces in this file name located in the home directory, called spaces in this file name. So let's log in first. So we change to Bandit 2 here. we put the password that we previously obtained. Now we are in. Now look, there is this file, and this file is actually spaces in the file name. So spaces in the file name. How can we cut this file? We can use either this kind of backslash that quotes that is used to escape the space, or we can just do in quotes. So this is a way, or we can just write the name in quotes. So once again, why do we have to do these kind of things? Because spaces in Bash, once again, have a special meaning, and they are the separator of arguments. Like if I do ls, then I do a space, and like, I don't know, dot profile, it's meaning something. If I do space profile, space bash rc, it means something. This means if I do ls spaces in this file name without proper escaping, either with backslash or with quotes, ls is gonna try to find the single files. So the file spaces, the file in this, and the file name. And of course, it's not gonna find anything. If we do cut of this, it's not gonna cut anything because it doesn't find these files, because it tries to like read the single files. Actually, we just have to tell the shell, which is in this case is bash, look, these are not 4 different files. This is just a single file which has spaces in them. And so the way we do it is either we put quotes around them to signify that it is a single entity, a single file, or we put this kind of backslash before the space itself, which once again, when the bash interpreter reads this command, it's going to take a single input here. It's going to take a single argument. It's going to treat it as a single entity. And this will allow us to read essentially the password. So we can sign this very fast. So let's do Bandit level 2. And we do, let's copy this, cut and cut here. And then we have the password for the next level. And so also this level is done. So okay, we can go to the next, so Bandit 3, with the password obtained here. We log in and then we read the next prompt essentially. So, the password for the next level is stored in a hidden file in the in here directory. So now we're talking about hidden files. So as you can see, the OverTheWire is made you to get familiar with the basic functions of the file system, of Linux commands, and so on and so forth. So in this case, let's try to, there is an in here directory. And if you do ls like this, we say, look, there's 0 files here. However, when you just do ls like this, it doesn't actually obtain all the files that actually exist in the directory, because it skips all the files that contain a dot in them, that start with a dot more specifically. To obtain also those files, we have to use the A flag, the A option. Because if you do into ls help and you check, like in this case, you go and check the /a. So like, let's go and look at the /a, not this, all. It says, do not ignore entries starting with dot. So these are called dot files, and they are typically ignored because most programs configure their environments and their functioning with so-called dot configuration files. So they are configuration files that start with a simple dot. Now this is why typically by default these are not shown, because they can be many and they can be confusing. However, sometimes special files, also for security, you need to read all the possible files in the directories, including the hidden files. So in this case, we have this hiding from you file. How do we read it? Well, we can do cut. Let's do cut hiding from you, and we obtain this. We can also do cut. In this case, we don't need to quotes because it's a single entity, essentially. And so we have, it's like we can show how we obtain the file, and we can show how we read the file. Very, very simple, but at the same time, if you've never seen this stuff, it can be interesting, let's say. So here the command is lsa to view hidden files, and then we can just carry it out. And I would say actually here it makes sense to just put the entire output of ls, because it can be useful to just see. And then we put the password itself. And once again, level 3 is done. Okay, so let's go into Chromium, let's go into level 4, and here logout, Bandit 4, we put the password that we obtained in level 3, and we are in level 4. Perfect. So let's read the prompt. The password for the next level is stored in the only human readable file in the in here directory. Tip: if your terminal is messed up, try the reset command. So interesting, in the only human readable file. So there is an in here directory. We go in there, And look at this, we have a bunch of files. We have file 0, we have file 1, we have file 2, we have file 3, file 4, file 5, and so on and so forth. Let's cut, for example, file 0. Now notice that nothing happens in my shell here, even though it has 33 bytes, because this number is the number of bytes. When I cut out the content, I see nothing. Why is this the case? Well, this is the case because not all bytes are human readable, as the prompt said. Some bytes are used for controlling the environment and for controlling the output. They are called control characters and they have no representation of textual character, like the ASCII character that we see, like N, O, S, U, C, H, and so on and so forth. Now, how do we understand what are the actual bytes, the just raw values stored in that file? We can use the command xdump, which is also the name of this channel, so it kind of makes sense to do it. So we do file 00. So we do file 00, let's go like this. Now these are the raw bytes. And notice that if we check the ASCII representation, for some of them, there is just a dot. When you check the ASCII representation of something and it's just a dot, it means actually that there is no corresponding ASCII representation. It means, for example, that the byte 84 has no ASCII character. It does not map to any ASCII character, while, for example, the byte 70 maps to the P character, and the byte 40 maps to the at character in the ASCII alphabet. So the idea is that with the ASCII, we are able to use some bytes to capture the characters, which are like, the digits, the letters, the special characters, and so on and so forth. But not all of the bytes, not all of the possible raw values that we can find in our computer memory. The remaining value are just like hexadecimal bytes, they're just bytes that do not have a corresponding mapping. Now, when we try to cut this content, the terminal is not able to process the file in a graphical way. It's not able to render the textual characters because there is no textual character, and therefore we see nothing. It can also happen that the terminal itself, graphically, it kind of breaks down, so it has some kind of graphical bugs. Let's try to see, for example, the file 01. Nothing happens. Like, look at this. It kind of looks weird, right? Why does it look weird? Because it tries to process a control character that maybe adds some space, like maybe this is a tab, could be a tab. So let's try to find the content, file 02. I'm not sure which is the tab character, but maybe one of these characters is the tab character, for example. So this is why it added this kind of tab to the output. So like a new line and a tab. I think the new line is 0A. So I'm not sure if there is a 0A. I don't see a 0A here either. Anyways, as you can see, it's really difficult to check those files. Now, how can we quickly understand which of these files contain like ASCII stuff? Well, we can sort of do it like this. What if we do xstamp, we do a wildcard, then we do a -c wildcard, can't read file, no such file or directory. Okay, what if we do a cut, and then we do an xstamp -c like this, invalid option, let's do invalid option -f, let's do cut like this. Okay, look at this. Now this command works, and it actually uses what I said before about the double dashes. So this first command does not work, because when we use the wildcard, what's gonna happen is that this command is actually not the one executed by the shell. There is a first step of processing where we take all the various file names and we put them within the command. So essentially what we do is, so we say like file 0, so it's gonna be like this, file 0, file 01, file 02, file 03, and so on and so forth. Now if I execute this command, cat is gonna be like, wait, I don't have the -f option. I don't consider that. So this command does not work. However, if we do this instead, so look, if we do this, cat -- wildcard pipe xstamp, it's gonna be like cat -- and then this. So this presence of double dashes, cat knows at this point that all the following things that happen are essentially just arguments. So they're just file names, they're not commands. So I think we can even remove this one at the end. So we can remove that one at the end, and if we just cut that, we see the content. So of course we want to do it for all the files in here, so we just do this this thing, which is much faster. And as we can see here, we have merged all the files together into a single file, and we are able to quickly check the ASCII. And look at this. This is the actual content of the file, which probably means that it's either it's among the last one. So probably it's about, let's see, file 07-C, of course. Yes. So it is file 07. I mean, this I just look at in the, intuitively, but you can understand that by doing this, you can extract, oh look, there's a sequence of ASCII characters. You can also do this, which I think is fun, strings. So with strings, what you're doing is another command, and this pipe character, by the way, that I did not mention, is used to take the output from the cat command and give as input to the strings command. So cat is used to combine all the bytes, and then strings is used to say, okay, I'm just going to extract consecutive sequences of ASCII bytes, that is, of bytes that map to ASCII character. And I want consecutive bytes because that is essentially how we can define a string. A string is just a sequence of ASCII bytes. For example, in this case, I have the B byte, which corresponds here to the 62, but then the D5 is not an ASCII character. Therefore, consecutively, I lose the string. I have no string anymore. And in this case, we find these three strings. Of course, the first and the last do not make sense, but the second is long enough to represent a password. So that's the way we can move on with this particular level. So they are getting more interesting, as you can see. So for example, in this case, we can see this one. I'm gonna just put the entire output. Then I'm gonna put this thing, which is also interesting. And then we can put the actual file itself, which is file 07. And so the password ultimately is, the password value is this one. So once again, with level 4, we're done. And here in level 4, the main takeaway is that the terminal can only render a subset of the bytes. So ASCII bytes with some special characters like the new line, the tab character, and stuff like that. If it receives other characters, it can just bug itself out. It can render into glitches and stuff like that. So this is level 4. So we can go into level 5. So let's go level 5, level 6, and we say, okay, the password for the next level is stored in a file somewhere under the in here directory and has all of the following properties. It is human readable, it has a specific size, so 1033 bytes, and it is not executable. So all this information brings me to the command find, as we will see. So first of all, let's get out of here and let's go to the Bandit 5 labs. I put the password and I am in here. So let's do in here. So notice here we have a sort of a recursive structure because we have many subdirectories. So how can we satisfy all these conditions? In this case, the command to use is the command find, which is very, very helpful because with find, we can search on the file system for specific queries. So for example, if we just do find dot, we're gonna find all the files in the current directory, including recursively searching, so including nested directories. However, we are not just interested in finding, also this one finds also directories themselves. So it just finds everything. So to lower down the search, we can also search for only files. So we do -type f, -type file. So here we remove all the directories. Then we have to say that it is not an executable. So we put not executable like this, executable. And here we have all the not executable. And finally, we search for the specific size, which is 1033 in bytes. So we put the C at the end to signify that we want to search in bytes. And look at that, we have a single entity, and this single entity has a bunch of, look at this, when you see these kind of things, it's because I've printed some ASCII encoding characters and something else. So if we just extamp this thing, we have a lot of 20, which is that the tab? No, it's just a space. The 20 is just the white space, and the 0A is the new line. So we have the flag, the password, new line, all white space. So that's the idea. So we can just write these commands here for the 5th level essentially. So I always suggest to use extamp if you don't know what the file contains, because it's an extremely useful command. I mean, this is why I named my channel extamp after all. So this is useful. So untabify, okay, in okay? And the password itself is of course this value, so that we can go to the next level. So here the question can be, okay, how do I understand how to use the find command? You can use Google, you can ask ChatGPT, just make sure to test it out, of course. You can use the option, you can do find help. With find help, we can see, okay, let's see size. Size, we have N, we have the number, and then we have B, C, W, and stuff like that. And if the help menu of find is not enough, you can just do man find, and you can like, this is like way more in-depth documentation. Like the back points, like with this, you have essentially all the information that you need. And you just read this, for example, look at this, size N, and we have C for bytes, W for 2-byte words, K for kibibytes, megabytes, GB bytes, and so on and so forth. So that's the idea essentially, and we were able to finish also this level. So this is the password, so let's go to the next one, Bandit 6. So we put the password here, we put on here, we go to Chromium, and we check the documentation. So the password for the next level is stored somewhere on the server, so this time is on the entire server, not on a specific directory, and has the following properties. It is owned by user Bandit 7, it is owned by group Bandit 6, and it is 33 bytes in size. So once again, it's going to be about the find command, but this time it's a different thing. So let's actually, so not this shell, okay, Bandit 6, that's good. So let's search for mend. And let's search for like user. So let's see the backpoints, regex warn. Let's do find help grep user, and then the name of the user. So we do a find dot. Actually, let's not start from the dot, because starting from the dot means starting from the current directory, which we don't want. We actually want to start from the /root directory. So we do find /, then we do size 33C, then we do user bandit 7 and group bandit 8. So of course it says permission denied, all permission denied. Let's then eliminate these errors by printing the standard error to the dev null. Let's see if we find something like this. We don't find anything like this. Oh no, because it's actually user bandit 7 but group bandit 6. Okay, look at this. We found this file and it contains the password, so we are good. And here the trick was once again using find, so the password is this one, but the flags for the find command this time were, okay, I want to search from the root file system, not from the current directory, because I want to search the entire file system. The size of the file once again is 33 in bytes, so we do C to signify in bytes, and I know that the file is owned by the user bandit 7, but by the group bandit 6. And finally, since I will have a lot of permission denied error because I'm searching the root file system, therefore recursively the find command is also searching the root directories like /root, I have to just ignore the errors, so I redirect the standard error stream into the dev null driver of the kernel. And this essentially means ignore the errors and just keep going forward. So we finish this level and we can go into the next level. So let's go from here. Let's use the password here. So we do exit, we do bandit 7, and we use the password. Okay, so let's do level 7 to 8. The password for the next level is stored in the file data.txt next to the word million. Okay, interesting. How big is this data? It's 4 megabytes of data. So if we cut this data, you're gonna see a lot of different text clearly. And we have a lot of different potential passwords, but we just care about the one which is next to the word million. So now the objective is, how can we filter to just the results we want? So here comes the command grep. So essentially we can pipe the output of cat into grep, and specifically by grepping for this specific string, it's sort of like we're saying, out of all the possible strings, I just want to extract the line that contains this specific word, which in this case is millions. And look at this, we have our password. So this is the first step that you can do. Let's say then that we want to programmatically extract the second column. Now at this point, we can use the program cut, and we can say, look, I want to cut, I want to divide by the white space, I want to take the second column. Actually, let's do like this. Okay, without the divider, because maybe the divider here is the, okay, now it's the 4 white spaces. Essentially, with this cut command, you're saying, look, I want to extract the second column. So this is the first, and this is the second. So you combine these programs together, and with the cut, you extract all the data. With the grep, you extract only the line you're interested in, and with the cut, only the column of the line. So we can combine all this data together to get the final password. And using grep is an extremely useful tool that you can also use to encode reviews and stuff like that when you have to analyze some code. So this is it. Actually, let's just cut all of them, to be honest. So we have a bunch of outputs here, and I'm gonna put this and this. Perfect. So the final password is this one, which we can use to access the level 8. So we do exit, bandit 8, we put the password, and we are in. And we can read the prompt for level 8 to 9. So the password for the next level is stored in the file data.txt and is the only line of the text that occurs only once. Okay, very, very interesting. So if you look into the directory, we see this data.txt file, which is 33 kilobytes of data. And if we carry it, we see a bunch of different passwords in the different rows. So how can we extract the only row that doesn't repeat? Well, we're gonna have to concatenate three different commands actually. The first one is the sort command. We use the sort to sort out all these sequences so that consecutive sequences of the same type, they just happen one after the other. So notice this, we have like stuff that repeats, right? So at this point, we just want to use the unique program to list out for each group how many occurrences of that particular group there are. So we say unique.-c, and we have, okay, for this group we have 10 occurrences, for this other we have 10 occurrences, for this other we have 10 occurrences, and then we just want to grep for 1. Okay, if we grep like this for 1, of course, it's just not gonna work. So let's try to grep for 1 and then space. If we grep for 1 and space instead, it kind of works. We get the only occurrences we get the only password that has 1 occurrences, which is exactly what we want actually, right? So this is the way to solve this level. We do cut the data, we sort the data, we do unique, and then we do grep. Notice that if we don't do the sorting, we just do the unique, the unique program is actually not gonna work, because the unique program has to have consecutive, has to work with a already ordered set for it to produce meaningful results. Otherwise, it just doesn't work. So this is why we have to sort first. And so with this, we have the password, which in this case is this one. So we can mark level 8 as completed. We can exit, and we can go into level 9. Notice also that this kind of skills is useful regardless of these games. Knowing how to sort, how to grep, how to group together by occurrences can be extremely useful when you have to process data in a Linux system. So let's go level 9 to 10. The password for the next level is stored inside the file data.txt in one of the few human readable strings preceded by several equal characters. So, very interesting. So let's say this data, it has 19 kilobytes, and it's actually like a lot of hexadecimal bytes here, clearly. And if we just look at it, so how can we understand this? So once again, we can use the strings command on this thing, and then we can grep for like the single equal characters. So we boil down to these possibilities that we can just then analyze normally, because look at this. This is actually the password. So very, very simple, but also effective. This is level 9. So of course there are many ways to solve these challenges. The fun way is just to use your own method. There is no, it doesn't make sense to describe all possible ways. What really is useful is understanding how this method works and why they work. For example, in this case, the strings command is useful because what it does, as I said previously in a previous challenge, it tries to find consecutive ASCII characters. And for the strings command, consecutive ASCII characters are exactly strings. So in this case, we know that we have a strings because we have a bunch of equal signs, then a white space, which is also a character, and then the password itself. So this sequence of bytes in here that map to this are the one we want. So very, very useful and also fun to do. And then at this point, we are at the final level that I will bring today. Of course, I'm not gonna do the entire Bandit because that's like a lot of levels, but I just want you to show how it's done so you can finish the series yourself. If you are interested in more episodes, of course, let me know, I can think of it. So let's read from 10 to 11. So the password for the next level is stored in the file data.txt, which contains base64 encoded data. So let's first of all log in into that level. So we exit here, we do bandit 10, we put the password we found previously, and we are in. Okay, so if we check this data.txt, look, it contains few data, like doesn't contain many data points, but it contains this string, which is base64 encoded, which means that if we extamp this, this is not really ASCII encoding, right? This is just, I mean, this is ASCII encoding, but it doesn't make sense in terms of English. It's base64 encoded data. To actually read it, we need to decode it. So we can carry it out and put it into base64 decode. So base64-D for decoding. And we obtain the actual ASCII, the real text, the decoded text, which says the password is, and it gives us the password. And also, this is why, by the way, encoding is not a security operation, because anyone can decode it. There's no need for any sort of secret to use in the operation. If you encode something, anyone can decode that. So don't think that base64 adds security, because it doesn't. It just is, it just changes the representation of the bytes, but anyone who knows what encoding was used can do the inverse operation and decode the data. So in this case, the password is that, and we are able to essentially use it. So we finish with level 10. Let's just check that the password is correct. For example, just to clear with the base64 encoding, let's say that I want to encode hello world. I do hello world and then I do base64 and that's it. And it's gonna encode the thing. For example, in this case, if we want to encode this message, we can do echo this thing, we do base64, and notice what we get the same text as before. This one is the same as the one that we saw before. And they are the same because base64, of course, is not a probabilistic encoding scheme. It encodes in the same way, essentially. So this thing that we read initially was because they, before making the challenge, they just echoed this string and they give it to the base64 encoder. So this is very simple. We test out this password and then we're good. Exit bandit 11. I put the password and I have a different challenge. So I leave you all the rest of the exercise to you because I think it's extremely useful to just try it yourself. As I said, I hope it was enjoyable. I hope this is like a small and fun challenge that can allow you to get used to the Linux shell. This is particularly useful when you don't have much experience and you want a structure to your learning. You can use these wargames. Bandit is the first level, of course. There are other levels that have to do with other stuff. Like for example, this is about cryptography and so on and so forth. So just start with Bandit, get used to the Linux shell, and then do more difficult exercises and challenges. If you're interested in more of this content, just let me know and I will think organized to bring more of this content. And so this is it for this video. If it was enjoyable, leave some feedback, subscribe to the channel and share this video with like-minded people so that you can help me grow. Thank you and see you to the next video.